we will see how to draw orthographic projections. To learn the orthographic projections, a step-by-step procedure we need to follow. First one is the projection of points. The second one is projection of lines. Third one is projection of planes. Fourth one is projection of solids. That means projection of points 0-dimensional, projection of lines 1-dimensional, projection of planes 2-dimensional, and projection of solids 3-dimensional. That means one by one, a systematic procedure if you follow to learn the orthographic projections, that gives a clear idea about the orthographic projections. Now we will see projection of points. Projection of points. Note down the first problem. A point P is case 1, 25 mm above HP and 20 mm in front of VP. That's the first one. Point P is 25 mm above HP and 20 mm in front of VP. The second one is the point P is 25 mm above HP and 20 mm behind VP. Behind VP. The third case is point P is 25 mm below HP and 20 mm behind VP. Fourth case, point P is 25 mm below HP and 20 mm in front of VP. Next, fifth case, point P is lies in the both HP and VP. Okay, these are the 5 cases we can consider for point P, and we need to draw this by keeping a distance of 25 mm in between the projectors. Draw the projections. Draw the projections by keeping 25 mm in between projectors. In between projectors. Okay, this is the problem. Right. Now, first observe in which quadrant the point P lies in each case. Now, see the first case. In the first case, point P is 25 mm now we will see like this. Right. First case, 25 mm above HP in front of VP. Okay, therefore it is in first quadrant. Okay, the second one, 25 mm above HP, behind VP. This is second quadrant. Okay, third one, below HP, behind VP, third quadrant. And next one, 25 mm below HP, 20 mm in front of VP. Therefore it is fourth quadrant. Right? And lies in both HP and VP. If it lies in both HP and VP, obviously it is in the reference line. It is on the reference line. Right? Now, we will draw the respective projections. For all the cases, we can consider a common reference line. This is the common reference line. Let it be X, Y. And here 5 cases are there, and asked to draw the projections by keeping 25 mm in between the projectors. That means, suppose this is one projection line. From here we need to keep 25 mm. Another projection line. By keeping 25 mm, another projection line. By keeping 25 mm, another projection line. And by keeping 25 mm, another projection line. Okay? 5 cases. Consider first case. 25 mm above HP. Okay? If it is above HP, it is visible in the front view. Okay, and the front view obtained on the VP, okay, and above HP, this distance also visible in the front view. Therefore, we need to keep 25 mm here to here. Let it be 25 mm, and we need to mark the respective point, and it is the front view. And for the front views, dashes I will use. That there is P dash, right? Now 20 mm in front of VP. If it is in front of VP, in the top view respective distance we can see after the rotation it will goes to below horizontal reference line. Okay, and the projector is same. This is 20 mm. This is P. Okay, here to here. 25 mm, this is 25, and here to here, this is 20 mm. Okay, now go for the second case. In the second case, 25 mm above HP. Above HP, that is visible in the front view. 25 mm. Okay, therefore this is the front view, P dash, right? Next, 20 mm behind VP. If it is behind VP, in the top view, that distance 20 mm we can see. After that, if we rotate the horizontal plane, if you rotate it like this front top view will overlaps, or it will be lies in the projector line of a front view. Okay, and at a distance of 20 mm here, we need to mark P point. Okay, now you can observe this is 25 mm. And this is 20 mm. Right. Now come to the third problem. 25 mm below HP. If it is below HP, it is we can see that distance in the front view. Okay, and it is below HP. That means it is below the reference line. Therefore, below the reference line 25 mm. This is front view P dash, right, and it is 25 mm. This is 25. This is 25. Next one. 20 mm behind VP. It is below HP and behind VP. If it is behind VP, that distance we can see from the top. After the rotation of a horizontal plane, the top view will be above the reference line. Therefore, above the reference line at 20 mm, we need to mark the point. This is top view. This is 20. Right. Next one. Come to fourth problem. In the fourth problem, 25 mm below HP. So if it is below HP, the front view is below the reference line. This is P dash. And this is below HP. 25 mm. Right. Next, 20 mm in front of VP. In front of VP, it is visible in the top view, and after the rotation of horizontal plane, this 20 mm will goes down, and the projector of the point P in the top view exactly overlaps on the projector of the front view at 20 mm. You need to mark it. Okay, let it be 20, and this is 20 mm. Right. Next one. This is P. P indicates top view. Now come to fifth problem. Lies in the both HP and VP. If it lies in the both HP and VP, obviously it is on the reference line. Okay. Therefore, a point you can put here. That means in the top view, if it is on the reference line, the top view is on the reference line, and front view also on the reference line. Therefore, this is P top view and this is P dash. Okay, both are same. Okay. Now, on the drawing sheet, this is the projection of points. That means it need to visible on the drawing sheet only points. These are all constructional lines. Okay, reference line, it need to be visible, and the points need to be visible. Therefore, you need to darken these points to make it visible. Okay. This is the one problem. We will go for the next problem. A point P is 15 mm above HP and 20 mm in front of VP. Another point Q is 25 mm behind VP and 40 mm below HP. Draw the projections of P and Q, keeping the distance between their projectors equal to 90 mm. Draw the straight lines joining their top views and joining their front views. Now, if you see this problem, 2 points are given. One is P, other one is Q. P and Q. These 2 points are given in the problem. And P is in one quadrant and Q is on another quadrant. Okay. Now we need to keep a distance of 25 mm in between these two, and we need to draw the respective projectors. Now see, we can note the given data. Point P is 15 mm above HP. 15 above HP. And 20 mm in front of VP. Next, point Q. Point Q is 25 mm behind VP. 25 mm behind VP. And 40 mm below HP. And the distance in between the projectors, distance in between the projectors of P and Q equal to 90 mm. Right. Draw the projections as well as draw the lines in between both front views and both top views. This is a beautiful problem which gives a concept related to the projection of lines. Right. First, try to imagine where these points are. See, we know this is principal plane. This is principal plane. Right. Okay. Now, point P and point Q. Distance in between these projectors equal to 90 mm. Therefore, keep 90 here. Next one. The point P above HP 15 mm. This is above HP. This is 15. Right? Next, in front of VP 20 mm. This is 20 mm. Now, if you draw construction line like this, this is the position of point P. Okay? To distinguish it, I will use another. This is 15 mm and this is 20 mm. Right? This is 20. And position of point P here. Distance of 90 mm. The distance in between the projectors equal to 90 mm. Therefore, see, it is behind VP 40 mm below HP. Okay, behind VP 25 mm. Okay, therefore, behind VP, let it be 25. Right? Next, below HP 40 mm. This is 40 mm. Now, respective position we can draw. This is the position of point Q. P and Q. Now we can say P is in the first quadrant, Q is in the third quadrant. Okay. Now, respective projectors we need to locate. This is the direction of front view. Therefore, this is front view P dash. and Q front view here. This is Q dash. And P top view here. And Q top view here. This is Q, this is P. Right. In the problem, it asks you to draw a line in between two front views. This P dash, Q dash, both are in VP. Right. Similarly, in between P and Q top views, asked to draw. Okay, these 2 points are in HP. Right? After that, we need to rotate it. Okay? Even though this problem seems to be simple, the same problem we can ask in terms of line also. A line PQ of a length, a given length you can consider, and the end projectors are at a distance of 90 mm, and point P lies in the first quadrant, point Q lies in the third quadrant, and draw its projections. Like that also it is related to projection of lines. Now we will draw the respective projections on the 2D plane. Student, no need to draw this diagram on the drawing sheet. For the understanding purpose only, I drawn there. Now, orthographic projection. This is X, Y reference line. And we know the distance in between the projectors of P and Q, it is 90. Therefore, draw a constructional line here, and here also a constructional line, thin line we need to draw. Now by considering P 15 mm above HP, this is front view, and 20 mm in front of VP. Then after the rotation of HP, it is below the reference line. This is P, top view. Now come to Q, behind VP and below HP. Suppose if it is behind VP, below HP first we can write. Okay, below HP that we can see in the front view. This is 40 mm, right? And this is front view, this is Q dash. And behind VP 25 mm, after the rotation it will come or it will move above the reference line 25 mm behind VP. Therefore, here it is 25. Q. Just stop you. Now, as it is asked in the problem, we need to draw a line in between P dash and Q dash, and in between P and Q, that is both the top views. Right. Okay, this is the solution of the problem, and you can compare this solution with the solution obtained on the principal plane so that it gives a clarity on the problem. Right? Now we will go for another problem. Two points A and B are in the horizontal plane. The point A is 30 mm in front of VP, while B is behind VP. Distance is not given. The distance between their projectors is 75 mm, and the line joining their top views makes an angle of 45 degrees with the XY reference line. Find the distance of the point B from vertical plane. Okay, now first try to understand the given problem clearly, right? Now 2 points are given, one is A and another one is B, and A and B, both the points A comma B, both the points lies in the HP, horizontal plane, right? Now point A 30 mm in front of VP, point A 30 mm in front of VP, right? Next B, the distance we need to find, it is not given in the problem. Next one, the distance in between their projectors is 75 mm. Okay, distance between projectors 75 mm, right? Next one, a line joining the top views makes an angle of 45 degrees with XY reference line. Therefore, line joining their top views makes 45 degrees with XY reference line. XY reference line. Now try to imagine the same thing on the principal planes, right? This is the vertical plane. This is horizontal plane, right? Both the A and B points lies in the horizontal plane. The distance between the projectors, this is equal to 75 mm. This is 75, right? And let it be point A. A is in front of VP 30 mm. Therefore, mark A here at a distance of 30 mm. Next, B also in the HP, but it is behind VP, that is given in the problem, but what is the distance, that is not given, but it is behind the VP, right? Line joining their top views. See, if you see the front view on the reference line, this is the front view. If it is A, this is A dash, and here the front view of the B point, B dash, right? Now the top view is this one. It is obtained on the horizontal plane. This is the top view A, and this 30 mm. And if you draw a line with 45 degrees, see, here it is 45. If it is 45, this is 90, this is also 45 degrees. Okay? Therefore, we can consider that and we can draw the line, and it gives an intercept here, and this is the position of top view of point B. Okay? Now we will draw the same in the drawing sheet. See, this is XY reference line, and A is in front of VP. It is lies in HP and in front of VP. That we can see in the top view. After the rotation, it is below the reference line. Therefore, draw a projector and locate 30 mm at the distance of 30 mm. This is 30. Right? Next, from here you can draw a 45 degrees line. Okay, this is 45 and this is also 45 because this is 90. This is A and this is A dash front view. Now, the distance in between the projectors equal to 75. At a distance of 75, this is B dash, and you need to draw a vertical line that will cut here, right? This is B top view, right? And this distance we need to measure and we need to write here.